Yo, what's up guys? Today we're going to be going over the integral x to the 1/4 times log x dx. And first off, we can tell that this is integration by parts simply because there's both a log x and x to the 1/4. You can rule out u sub pretty quickly, and there's nothing else that would really work. Obviously, you can't integrate according to just like normal like standards practices. So we're going to have to use integration by parts. So to figure out what our u is, we need to remember the phrase liat, and this stands for logarithm, inverse, um, algebraic, trig, and then exponential. Basically, this is like your ln and log. This is like your arc sine and stuff. This is your a is your like algebra, like x to the 1/4 or x squared. Basically anything with like just x. Um, your trig, like your sine and your cosine, not your inverse, and your exponential, which is like your e stuff. So we know that u, if you look up from up here, from the formula, u is equal to log x dv is equal to x to the 1/4. Okay. So essentially what we're going to do is we're just going to solve and like plug in. Okay. So uv, the integral of x to the 1/4 is equal to 4/5 x to the 5/4. You can get this by just adding plus 4 and then putting the reciprocal out here. So if you add 1 to 1/4, you get 4/5 or 5/4, and then you put the reciprocal out in front, which is 4/5. So when this multiplies down, it cancels out. Okay. So this is our v. Okay. Let me rewrite all this in a different color. Oh, not the same color as as what I started with. Okay. So uv, oops, 4/5 x 5/4, and then you can either write like ln x, or I'm just gonna write log x because it's what we kept, minus you see I did u, which this is our u, just the log x, and then our v from up here is just this. Okay. So and then we're doing v du. V is this, is what we just found, and then du, if you know log x, it's just all this over x dx. Okay. I guess you might dx here, and then if you write du is equal to 1 over x dx. Okay. So this will cancel out with most of this, or with you basically just divide by x, because this is up top. Let me rewrite this. This is just 4x to the 5/4 over x over 5x. Okay. So you can cancel out the x by just minusing 1 from the exponent. Like if you had, for example, like if you had x squared over x, this is just x, essentially. It's just simplification. Okay. So you have this is equal to 4/5 x to the 1/4. What you can do, dx. What you can do is put this out in front. So you get 4/5 integral x to the 1/4 dx. This is what we just solved for up here. So this is just going to equal 4/5 times 4/5 times x to the 5/4, which this is just 16 over 20 times x to the 5/4. Okay. So So then we need to minus this from that. So we're going to do 4/5 x to the 5/4 log x minus that. And also when I did 5, it's 5 times 5, so this is 25. 5 times 5. Okay? So from here, it may look like there's just no way to simplify. Plus c, by the way. It may look like there's absolutely like no way to simplify this. And if you wrote this on a test, this would be right. But you can simplify it even more if you do 4x to the 5th to the 5/4, and you just take a 4 out of it, so you get ln, or let me keep with log, minus 4, kind of looks like an 8, minus 4, and then do all this over 5 plus c. This is the most simplified. If you see what I did, I just took 4x to the 5/4 out of the top, 16 times x to the 5/4. If you take this out of it, that's just 4. So there's the 4 here, and since this is just the same thing, I just keep log x, and then yeah. Also, this is not over 5. This is over 25. So yeah, this is your answer. It's really not that bad once you get past all this. Once you get past all the integration by parts. So yeah, thanks for watching.